Hey guys, welcome to ED Technology and my name is Navjot Singh Jadeja, and in today's video we are going to discuss on Z-score normalization, which is also known as zero score normalization. So in the earlier video, a video before this, we have discussed what exactly the normalization is and why do we need it. A quick revision in here again. So basically many machine learning algorithms attempt to find trends in the data, and in order to do that they compare different features or data points. However, there is an issue in here. When the features are on drastically different scales, right, then it can lead into errors, and that is where we need normalization. So normalization is a set of techniques which we can apply on the data, especially when they're coming from different scales. Like the example which we have given in here is one of the relevant one, where distance is either measured in miles or kilometers, and we might have data coming from different kind of scales and we want to normalize the data. So in earlier video we have seen min-max normalization, which is one of the popular techniques of normalization, and in today's video we are going to talk about z-score normalization or zero score normalization. In this technique the data transformation is done by the values where the conversion is done on a common scale, where an average number equals 0 and a standard deviation is 1, right? So a value is normalized. Like how do we normalize? So that is what I'm going to explain you here. In a general scenario there will be some values given in here. So one is x is value for which z score is to be calculated. So z score is what we will get in the end, and x is the value for which we are calculating the z score. This is a very familiar symbol. It is mu, it is for mean. So in some cases the mean would be given for the value, and if it is not given, it is very easy. You can just, mean is like total of all the values divided by number of values and you get the mean. And in the examination, because this kind of sums are asked in university exams a lot, one parameter would be added here, which is standard deviation. So that would be given in here, and when you put up the value in here in the equation you get the z score, and the z score tells you how many standard deviations from the mean your score is. Let us see that by an example and you will understand it better. So as you can see it here, I've taken a solved example. So if the mean salary is 54,000 and the standard deviation is 16,000 rupees, then find the Z score for the value which is 73,600 rupees of a salary. So what do we do here is, this is our X. So we put up the value of X as in 73,600 rupees minus mu, which is the mean, which is 54,000. So you get this, divided by standard deviation, which is 16,000. So at the end, the z score when you get this value is 1.225. So that is your z score, and we will be doing the similar kind of sum again so that you understand how we are calculating. This time around values are taken into dollars. So again, if the mean salary is $65,000 and the standard deviation is $18,000, find the z score of the value which is 85,800 as in the dollar salary. So what do we do here is, again 85,800, let me highlight this in here. So this becomes your x, the value which we want to normalize, right? This is your mean. So this value will come here with the mean value, and this standard deviation is in the denominator, right? So we get 85,800 minus 65,000 divided by 18,000, which gives us 1.15555, which we rounded up to 1.156. So this is how we normalize the value using the z-score normalization. Also, a small technique which I'll be discussing in here is also taught in a lot of data mining subject, machine learning subject, which is one extension of z-score, which is known as z-score normalization using standard error of the mean or using standard deviation. So again in here what are we doing is, we have an example, we'll try to calculate using that. So most of the things remain the same. Let me take up my pen. So this particular part remains the same. but the denominator is no more the standard deviation. Now it's the standard deviation or mean deviation, right? Which is standard error of the mean. So let us take one more example. In general, the mean height of the women is 6.5 with a standard deviation of 3.5, all of them in inches. What is the probability of finding a random sample of 50 women with a mean height of 7 inches, assuming the heights are normally distributed? So what do we do is, how much are the number we are calculating is given here, which is 50. So this value will come in here. Standard deviation is what we have got as in the 3.5, right? Mean is something already specified in here, which is 6.5, and what we are calculating is for 7 inches, right? So for 7, and that is why like I've converted all the values into normal form. So it is 70 minus 65 divided by 3.5, and root of 50 is equal to 10.1. So this is another method which tackles outliers much better than the earlier method which we saw in here, right? Because here we are taking standard deviation. Imagine I have the height of the people as 3.5, 3.7, 4.5 and 7.5. So the average or the mean will come as different. So here this method converts the outliers better. So in this way we can use z-score normalization to perform normalization on different types of data. So, now one more important thing which I'd like to ask you at the end of this video, which is very important, which only your support can do. If you like our effort of teaching different topics of data mining, programming, etc., then please like the video, share the video, and hit that subscribe button so that we can reach out to more people and we can teach more and more people. Thank you so much.